All right, units are amazingly important in mathematics, science, and engineering. They're how we decide on what constitutes the number 1. For example, 1 gallon, 1 pound, etc. We often need to convert from one unit to another in practical problems. In this situation, we can almost always use proportional reasoning to do the job. So in exercise 1, John has traveled a total of 4.5 miles. If there are 5,280 feet in each mile, how many feet did John travel? Set up and solve a proportion for this problem. Also, do the problem by multiplying by a ratio. So we know that there are 5,280 feet in 1 mile. And we want to know if this is proportional, how many feet are in 4.5 miles. And again, we're going to cross multiply. So we have this equals this. So 1 mile times x equals 5,280 feet times 4.5, which becomes x equals 23,760 feet. You could also do the problem by multiplying by a ratio. If we know that 4.5 mile over 1 times, 5,280 feet is over 1 mile. What cancels themselves out are the miles, and we know that 4.5 times 5,280 still becomes 23,760. All right, if there are exactly 2.54 centimeters in each inch, how many centimeters are in 1 foot? Show the work that leads you to your answer. So we have 1 foot times, we know that there are 12 inches in 1 foot times, and we know that there are 2.54 centimeters in 1 inch. So what we've done here is we have set it up so that we are starting with a foot right here, and we are ending with centimeters right here. So what you want to do is you want to set it up so that you cancel out the feet and you cancel out the inches. If you are multiplying by a foot but also dividing by a foot, then it cancels out. If you're multiplying by an inch but also dividing by an inch, then it cancels out. And all that's left over is the centimeter. So now you multiply by everything on the top and divide by everything on the bottom. Well, the only thing on the bottom are 1, so we're just going to multiply all the way across. 1 foot times 12 is 12. 12 times 2.54 is 30.48. And again, centimeters is the only constitute that is left. A bathtub contains 14.5 cubic feet of water. If the water drains out of the bathtub at a rate of 4 gallons per minute, then how long will it take to the nearest minute to drain the bathtub? There are 7.5 gallons of water per cubic foot. Show the work that leads to the gallons. So we start with 14.5 cubic feet. And we're going to multiply that by 7.5 gallons over 1 cubic foot. So what we've done here is we've set it up so that the cubic feet will cancel out. So this becomes 108.75 gallons is how many gallons there are in 14.5 cubic feet. Now we need to figure out how long that it takes to drain. So if T is time to drain in minutes, then 4 times T equals 108.75. We know that it takes 4 gallons per minute to drain. So 4 gallons per minute, and we want to know if there are 108.75 gallons, how many minutes is this going to last? So we divide by 4 on both sides, and T equals 27.1875, but we're talking about minutes, so it takes approximately 27 minutes to drain the bathtub. The mile and the kilometer are relatively close in size. Can you convert 1 mile into an equivalent in kilometers? Here's what I'll give you. There are 2.54 centimeters in an inch, 5,280 feet in a mile, 100 centimeters in a meter, and 1,000 meters in a kilometer. All else you should be able to do for yourself. Round your answers to the nearest tenth of a kilometer. This takes quite a string of multiplications, but you can do it. So we want to go from miles to kilometer. So let's start with 1 mile. So we want to go all the way from mile to centimeters because centimeters will take us to kilometers. So I need mile to be down here in order to cancel out. And we know that we can go from feet to mile. So in 1 mile, there are 5,280 feet. Times. Then we know that we're going to need to cancel out the feet. So from feet, we're going to go to inches. And in 1 foot, there are 12 inches. And then from inches, we know that we can go to centimeters. In 1 inch, there are 2.54 centimeters. Now from centimeters, we can go to meters. So in 1 meter, there's 100 centimeters. And then from meters, we can go to kilometers. In 1 kilometer, there's 1,000 meters. So now let's cancel out all of the labels we don't need. So miles cancel out, feet cancel out, inches cancel out, centimeters cancel out, meters cancel out. So we're left with kilometers. Now we just need to do the math. So we do 1 times 5,280 times 12. So 5,280 times 12 times 2.54 divided by 100 divided by 1,000. The reason why we're dividing is because we have this 100 and 1,000 in the denominator. Once you do all of that work, you find that it's 1.609 kilometers, but it says to round to the nearest tenth, so 1 mile is approximately 1.6 kilometer. We can also convert the ratio of 2 quantities or rates into 2 different units if we needed. So one interesting conversion is from a speed expressed in feet per second to a speed in miles per hour. We sometimes think better in miles per hour because that is how the speeds of our cars are measured. So we want to go from 45 miles per hour into feet per second, given that there's 5,280 feet in a mile. So there are 45 miles per 1 hour, and we need to cancel out miles. So in 1 mile, there's 5,280 feet. So we've done the first part. We have canceled out to find feet. Now we need to get to second. So we need to cancel out this hour right here. So in 1 hour, there are 60 minutes. And in 1 minute, there's 60 seconds. So now we have canceled out hour and minute and have ended up with feet per second. So now we do the math. 45 times 5,280 divided by 60 divided by 60. If you do that math, you find that it's 66 feet per second. So 45 miles per hour is the same as 66 feet per second. So the current fastest human is Usain Bolt from Jamaica. In 2009, Usain ran 100 meters in a blazing 32.2 feet per second average speed. How does this compare to a typical car driving speed? We know that car driving speed is miles per hour. So we're going to go from 32.2 feet per 1 second. And first, let's do the feet and make it a mile. So we need to cancel out feet, make it a mile, and in 1 mile, there's 5,280 feet. So we have already canceled out the feet and have ended up with mile. Now we need to cancel out the second. So there's 60 seconds in 1 minute. And then we need to cancel out minute to find hour. There are 60 minutes in 1 hour. So we have canceled out the seconds and the minute and have ended up with miles over hour. So 32.2 divided by 5280 times 60 times 60. Once you do that math, you find that it's 21.954 repeated. If we're going to round up to a typical car driving speed, that's approximately 30 miles per hour. A local factory has to add a liquid ingredient to make their product at a rate of 13 quarts every 5 minutes. How many gallons per hour of the ingredient do they need to add? Show the work that leads to your answer. So we're going to start with 13 quarts for every 5 minutes. And we're going to get rid of quarts first. So there are 4 quarts in 1 gallon. So we have done the first part by getting rid of quarts. Now we need to transfer minutes to hours because we want to know gallons per hour. So we need to cancel out minutes. There's 60 minutes in 1 hour. So we have canceled out minutes and we're left with gallons over hour. So 13 divided by 5 divided by 4 times 60. So 13 divided by 5 divided by 4 times 60 is 39 gallons per hour if you're doing 13 quarts per 5 minutes. A tractor can plant a field at a rate of 2.5 acres per 5 minutes. If a mammoth farm measuring 4 square miles needs planting, how long will it take in hours to plant the field? There's 640 acres in a square mile. Determine your answer to the nearest hour. If the tractor can run 8 hours a day, what is the minimum number of days it will take to plant the farm? So we're looking at 2.5 acres for 5 minutes. Before we can do anything, we need to figure out how many acres total that the 4 square miles are. So 4 square miles, we know that in 1 square mile, there are 640 acres. So 4 times 640 is 2,560 acres. So we know that we are trying to get this 2.5 over 5 to transfer to the number of acres that we're dealing with. So we have the 2.5 over 5, and we want to know how many minutes if we are looking at 2,560 acres. So we're going to cross multiply, and 2.5 times x equals 5 times 2,560. So 2.5 times x is 12,800 divided by 2.5, and it's going to take 5,120 minutes to do 2,560 acres. But now we know that the tractor can run 8 hours a day, so we need to know how many hours will it take to do this. So there are 5,120 minutes, and we need to transfer this to hours. So in 1 hour, there are 60 minutes. So the same thing as 5,120 divided by 60, which is 85.3. We're going to round that to 85 hours is how long that it's going to take. So we know that 5,120 minutes is the same thing as approximately 85 hours. And now we have to figure out how long or how many days, the minimum number of days it will take to plant the farm. So we have 85 hours and 1 day, but we know that it can only work 8 hours in 1 day. So 85 divided by 4.8 becomes 10.6, so it's approximately 11 days is our minimum number of days that we will need to plant the fields.